Morning, students. It looks like there's two of you on here. If you can hear me, I hope that you'll say something in the chat just to let me know you're in here and that you're able to hear me. So just say hello or something so I know who's here. Because based on what I can see, there's only two of you in here. Go figure. Now we're down to one. Morning, Lauren. Hope you're doing well. Proud to be a Jet and all that. Is anybody else on here? Morning, Emily. Hope you're doing well. I'm going to give people, oh, whoa, all of a sudden we doubled to 4 whole people. So, guys, as you get in here, please say something so I know who I'm talking to. So I at least have the illusion that I still have students. As people are joining, and morning, Cassie, hope you're doing well. Morning, Kira. Hope you understood my email yesterday about how you broke my stylus and I'll never forgive you. I'm just kidding. But anyway, I hope you can fix it. I hope that it works out for you. But yeah, the nib, it sounds like that's the part that came out. If you keep it all screwed together and you're able to get another nib or you're able to find the one that fell out, keep it all screwed together. You shouldn't have to unscrew anything and you just push it in until it's at the right place, and it's really easy to fix. All right, well, if anybody else shows up, they show up, but otherwise I'm going to go ahead and get things started. Yeah, so let's see. All right, so my plan, which according to my description, can I read my description on here? No, I can't. But my plan is to talk to you guys just a little bit about AP and where that's headed. So I'm going to give you some AP exam info really quick, and I will go as quick as I can, I promise, but it is pretty important. There's a lot of stuff to go over and a lot of information I got, I don't know, yesterday, day before. So I'm going to go over that, and then I do have Unit 7B if you guys have problems about that. Ugh, okay. Well, it'll get here when it gets here, Kira. But then you guys said that you had some questions about the 7B problem. So just have those ready. Go ahead and circle them or whatever you want to do so we can talk about those. And I'm going to do the best I can with them because my wife and I went over those, I don't know, 2 weeks ago. So it's been a while now. But I will do the best I can and we'll see what happens. All right. So let's go ahead and get things rolling and talk about some testing. So I got this information, like I said, in an email not too long ago. Here's some stuff. I'm going to talk to you guys about what you need to do shortly, but all that stuff is on OneNote, especially the checklist. The checklist is really important, and then you guys have access to this full presentation, so if you feel like I'm going too quickly, you can read this at your leisure another time. All right, so anyway, here we go. So, AP exam e-ticket. So if you guys remember, I told you like a week ago, I said, go ahead and sign in. Make sure you know the phone number and the email address and your password. Make sure you know all that stuff that's associated with your AP account that we did back in the fall. So if you haven't done that, please do that because this is how you're going to get your exam information. So they'll give you this ticket. It'll look something like that, and they're going to send it via email. So if you're in AP US History, you're going to get a separate ticket for that, and then you're going to get your AP Chemistry ticket as well. Don't share it. Don't do that. I mean, I don't know why you'd want to, but obviously keep that to yourself. So yeah, there you go. So as soon as you get that in the mail, it should be 2 days before the exam. Go ahead and have that ready. All right, so it is valid for the May exam schedule. So based on what I remember, most of you guys are in APUS. So it looks like, oof, We got chemistry at 2 o'clock on a Thursday, and then the very next day looks like that's the U.S. history exam. So that should be really fun for you guys. I don't envy you. But anyway, you can see the schedule here. So if you were registered back in the fall, which all of us were with Miss Burlingame, then you should be scheduled for these dates. So you should test in May, all right? And I know some of you are going to be like, oh, well, why wouldn't we just take the late date? Why wouldn't we just do it in June so we get more time? Please don't do that. I plan on being done with school in June so that I can focus on the summer, and I hope you guys will be too. So I don't know, don't plan on doing that. You can't test on, if you can't test, don't use your e-ticket for the exam. They'll just send you a new one for the one in June. So if you don't show up for your exam or you don't do what you're supposed to, they'll know and they should email you another one. But again, take your test on the 14th so we can be done with this. So yeah, I'm not even going to talk about the June dates because all of you are going to take it when you're supposed to. So each exam will happen at the exact same time. Like for us, we've already said we have a 2 p.m. Testing time. We don't need to talk about that anymore. All right, what to expect? And I already read over this earlier. Basically, it's not like it's going to be easier. It's not going to be more difficult to get a 3, 4, or 5. So if it looks like really hard and you're like, oh, how do they expect us to do this? Just do the best you can. And also, this is interesting. AP exams are never graded on a curve, but they sort of are. The thing is, when you guys take an NCFE, like a North Carolina final exam, it is on a curve because what they do is they say, okay, all of the students across North Carolina did a little bit worse than we wanted them to. We're going to bump everybody up a little bit. And they use a bell curve. But for the AP exam, that's not how it goes. The AP teachers and the AP coordinators ahead of time decide, what a 3 should be worth. This is what they need to have. A 4, this is what they need to have. They already have that stuff decided. So if it's a really hard question, they're like, as long as they did X, Y, and Z, we'll give them a 3. Oh, if they did all of this, they get a 5. They've already decided that. So if you don't complete all parts, okay, if you don't complete all parts, before you need to attach, yeah. You don't need to submit the entire question. So just do what you can. That's basically what they're saying. All right, so what to expect? Because of creating a good testing environment, the exam is shorter. You guys have probably already heard this. It's like 45 minutes, and it's 2 free response questions. Woohoo! So there are fewer questions, which is hard because you've worked for an entire year, and so it's difficult to think, how are they going to assess everything for the whole year? Well, they're just going to pick and choose, and hopefully, the questions they pick are ones that you're really comfortable with. Okay. You don't get a score of 3 or higher because of the shorter exam format. I can request a review and confirmation. I don't really know what that means yet, so we'll find out more about that later. Okay. Obviously, if I feel like you guys should have gotten a higher grade and I had the chance to ask for an appeal, you better believe I'm going to do it. So don't worry about that. All right, exam questions will be viewed by students in a web browser. Students are going to type or write their responses inside that, and you have 3 different ways. You can either copy and paste, like if you've already typed something from a Word document or something, you can copy and paste that into the web browser. You can attach a typed response from a typing document you've already used, or you can just attach photos. Like if you hand wrote your work, okay, they have an option where you can just send it in. And again, we'll look at each of these individually here in a second. And guys, if you've heard this information before, I'd really be interested for you guys to say, oh yeah, we already went over this in APUS. Like, tell me so I'm not, I don't know, beating a dead horse here. So option 1, copy and paste. So if you were typing in Google Docs, Microsoft Word, blah, 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 don't include images. You just have text only. You do need to type your AP ID, which you guys should know how to get that information in AP Classroom. And I think it probably will be on your exam ticket as well. So type your AP ID and initials at the top. And then when the timer has 5 minutes left, okay, they'll tell you. Then you can copy and paste over your information. So anyway, what they recommend that you do is they keep one window open where your exam questions are. And you guys know how to do split screen. Heck, I'm doing split screening right now. But have your one window that has your test information, and your other window you can have your typing software, whatever it is you're deciding to use, okay? All right, next thing, attach a document. So another way to do it instead of copying and pasting is you can save the document in that side window and then just submit that. I'm not sure why you do that if you could just copy and paste, but whatever. Main thing is just make sure you have your AP ID and your initials at the top of the response. Option 3, attach photos. All right, so this is the one I really want to focus on. So every page, okay, not just the first one, but every page that you're handwriting on, write your AP ID and your initials, and also put a page number. So just in case you're submitting a bunch of pages, it doesn't get really confusing for the graders. So make sure you number your page numbers. Excuse me. And then when the timer has 5 minutes remaining, you'll take it in the portrait mode. Okay, you take a picture portrait mode, not landscape mode. Not sure why they decided that was important. 1 page per photo. If it's more, you'll need to attach multiple, but you're only allowed to have 5 photos each. There's a certain student that I'm sure would love to do more than 5. I'm not going to call out who that is, and I don't want you guys calling out who it is, even though we all know who it is. But you can't have more than 5 pages. Okay, so keep it brief. Make sure to attach all of your pages before you click submit, and you can have a PNG, JPEG, whatever. All right. So have your smartphone or tablet. Okay, it should have the test question on there, and you can use that your device to take photos. So I think their plan here, they would rather you typed. Okay, I think it seems to me like they would rather that you type something than take a picture. But for whatever reason, if you're taking the whole exam on your phone or a tablet, okay, then that's when they want you to be taking pictures. All right, and again, if you guys want to look at this in more detail later, you can. This isn't music theory. This isn't world language. None of you have accommodations as far as I'm concerned, but if you have questions about that, email me or Miss Burlingame. If you need a makeup exam, here's some information on that, but I'm sure that won't happen. You guys are going to do what you're supposed to. Okay, here we go. Exam screen will guide students step by step on test day from the moment you click the e-ticket. So again, you're going to get that in an email. Okay, I'm not going to go back to it, but you already saw it. And when you take your exam on that test day, it'll take you to where you need to be. So most students will be able to navigate the test using only the information on the preceding slides. So all this stuff we talked about, you should know what to do. It's not that confusing. They're trying to make this as simple as possible. Unexpected events may occur when testing at home, and some students will benefit from additional preparation and technology checks. That's what I'd be doing. Yeah, it would probably be easier to handwrite your stuff in terms of work, but again, you guys do what you feel like you need to do. It does seem to me, though, based on what I'm seeing and what I've read, that if you are going to take photos, you should just think about taking the test on your phone. But then again, I mean, your laptops have a camera, it's just kind of crappy. So I'll leave that up to you guys. All right. So if it were me and I were taking the AP exam, especially in such a weird format like this, I would probably be doing as much preparation ahead of time just so I'd be ready. I recommend you guys do the same thing. Okay, 5 steps to take before exam day. Review your contact information. That's what I was telling you guys to do already. So make sure that you know what email address you used. Check your technology. Okay, and whatever document that you plan, like if you plan on typing in Microsoft Word, go ahead and be ready to do that. Practice submitting that. There will be an online AP exam demo on May 4th, so that's next Monday. Yeah, so that's on Monday. I highly recommend you guys do that. Okay, especially since a lot of you guys have multiple AP exams you'll be taking. Please go ahead and do that. All right, so do the demo, and then you can test these things, and you can decide, oh, do I want to do, handwritten? Do I want to do documents? You decide that. Okay, I can't tell what's going to be better for you. And then after you do the practice exam, gather what you'll need for each exam. So you can go to this document website, and that's where you can get your additional materials. This is where you can get things like your reference table and go ahead and have that printed out, or you can go ahead and have it downloaded up on your computer. Yeah, go ahead and get that stuff ready. If you don't have a calculator, please find a calculator. They even said you can use your phone as a calculator. I don't care if you use your phone as a calculator, but I think that, in my opinion, a physical calculator is always better. And then step 5, 2 days before the exam, you will get your AP ID and your exam e-ticket. All right, and you'll also be able to get that in AP Classroom, but I just think it'd be better if you had the email ready because that's what you can click and open up the exam. Okay, review your contact information. And again, you guys can look at this on your own time. I want to get things moving so we can get to going over some problems. So, review your contact information, make sure it's correct and up to date. You can read about that. Choose what device you want to use. Okay, you will not need to use the lockdown browser. Okay, if you do have the Grammarly plugin, because those YouTube advertisements are just getting to you, you need to disable it. Okay, if you don't know how to disable an extension, you go up here and right click, and you can go to Manage Extensions and delete it. It's not a big deal. You guys are smart. When choosing between handwriting and typing, keep in mind this year's questions will not require you to submit graphs or diagrams. And I am so disappointed because I love a good graph. You may be more comfortable handwriting responses in calculus, chemistry, and statistics. But if you want to type your responses, they have a guide that tells you how to type symbols and formulas and all that good junk in the AP Exam Day for docs page, and you can look at that on your own time. In most other subjects, using a smartphone will require scrolling back and forth within a question, which many students will find frustrating. So we recommend a desktop or laptop if available. So they're saying here, if you have the option to have a laptop open, just use a laptop. And I like that too because you can do split screen. That's what I'd be doing. Check your tech. Prepare your documents for typing. So decide what you want to use. They recommend turning on autosave. Duh. If you're using Google Docs, okay, remember you'll need to download it. So what that means is, like, if you're using Google Docs, which is what I bet a bunch of you will use, you can't share it with the AP test. It's not a person. So you'll have to download it as a doc file and then submit it. So that means it's a couple steps. But again, you can just copy and paste. So I don't really see what the issue is there. So yeah, before test day, so maybe the day before, go ahead and prepare your documents. Go ahead and have, everything ready. Maybe have your pieces of paper ready with your AP ID written on the top and your initials. Go ahead and have all that stuff ready. It is my hope for you all, because if it were me administering the test, this is what I would do for you, but I can't because I'm not there, is I would have, all your reference tables printed, ready to go. I'd have all my pieces of paper, ready to go with my AP ID. I'd have my calculator. I'd have everything ready and my workspace clean so that I was ready to go. Multiple pencils, sharpened. Okay. So anyway, there's some stuff. All other AP exams have 2 questions, so you'll need to create and save 2 documents per exam. So name them clearly so you'll know you're attaching the correct one at the correct time. So there you go. It's pretty straightforward. Prepare your documents for handwriting. Yep, use white paper. They don't care if it has lines or not. Use standard size. Use a number 2 pencil or a pen with black or blue ink. No red ink, y'all. No bright pink ink, y'all. No yellow ink. I was looking through a bunch of notes and I was surprised how many of you guys are using like gold gel pens. Fascinating. Because of the maximum number of pages, the most you'll need is 10 pages total. So think about that. Go ahead and if you want to do handwriting, go ahead and have 5 for question 1, 5 for question 2. And yeah, there you go. You get the plan. Use that demo day. From May 4th, you can access an AP exam demo. It will allow you to practice the different ways. So I think that's fantastic. That's really smart on College Board's part. So I recommend maybe trying it digitally, try the typing. And if you don't like that, try the handwritten way. So you've got multiple ways that you guys can try it. So you should be very comfortable. All right, so what you'll need. All right, and you can find all the documents on this AP Exam Day docs page. If you don't have a printer, figure it out. I'm sorry, but that's kind of how it is. You can't go to a library right now. You can't even go to the school, really. If you really want it printed and you don't have a printer, talk to me. I'll see if I can figure out something. All right, so all of this is required. You need your exam e-ticket email. You need your completed exam checklist, which we're going to talk about here in a second. You'll need your device fully updated. The browser they want you to use is Chrome because, of course, they do. They want you to have internet, obviously, and then assisted technology and devices if needed. And if that's you, you should already know about that. If you are like, I don't know if I need that or not, probably not. You'll need some type of document ready and permitted. This is fascinating. Okay, your class notes or your study guides. You can have a textbook. You can have all previous assessments or assignments. And if you're saying, but Mr. Nairn, that just seems like cheating. How could everyone not make a 5? Because it's 45 minutes. It's 45 minutes. You are not going to be able to just, oh, I got to look. Oh, that was unit 2. Hold on, I got to go flip through my notebook. All right, I got to read this again. Time is ticking. So you're not going to be able to just look through all your notes. So what I recommend, and we'll talk about this when we get closer, but what I recommend is having you one sheet of paper. And between now and the exam day, when we start doing reviews starting next Tuesday, start writing stuff down and saying, oh, that's something that, Mr. Nairn told us to memorize. Ooh, that's something that he told us to remember. Write it down on a piece of paper. 1 or 2 pieces of paper. So instead of looking through your whole notebook, you can just say, oh, I remember that. I wrote it on my one sheet. Okay. And again, you can have as many sheets as you want. It's just remember, the longer and longer your cheat sheet gets, the longer it's going to take you to find stuff. Some of you guys will thoroughly enjoy that, I'm sure. Okay. Music theory, who gives a crap? Stats. Here we go. Chemistry. Periodic table. And then your AP chemistry equations sheet. So we've already talked about that. If you are going to type, they have a whole document that tells you how to do symbols and whatnot. So your delta symbol, sigma probably is one of the symbols, your arrow, your double arrow for equilibrium, like all of that will be in that keyboarding tip sheet. So if you want it, there it is. And then obviously you can have a calculator. Alrighty, there you go. Yep. Optional resources. So you can have class notes, you can have previous assignments, calculators, shared study notes. You need to have, now this is interesting, must be downloaded to each student's device before. Okay, so you need to have it downloaded to your device. They don't want you downloading anything in the middle of the test. Okay, internet searches will waste your time and put you at risk of an exam violation. The more time you spend searching the web, the less time you spend answering exam questions. Okay, internet-based facts and opinions are not relevant. As with life, most internet opinions are not relevant, and they won't raise your scores. Copying from websites is considered plagiarism and will be detected, and scores will be canceled. And they have something right here, AP Open Book Tips. Please look at that. In fact, I will probably do that. Hold on, cb.org/open book tips. Wow, I got it first try. No, I didn't. Yeah, I did. No, I didn't. What the heck, y'all? I typed exactly what it said. Well, you know what? We'll look at that later. So take a look at that. There you go. They've already talked about that. Complete the checklist. We're going to look at that in a second. And then on exam day. All right, here we go. This is important. 2-question exams. Your timing is you need to be on there 30 minutes before the start time. Okay, you need to go ahead and click your e-ticket, make sure you get in there, complete the information, verifying your identity, and then you just wait. So if our exam starts at 2 o'clock, at 1:30, you guys better be in the check-in stage. Okay, you need to be clicking in your browser, have everything ready in front of you ahead of time. Okay, 25 minutes. Okay, at 25 minutes when the thing finally starts, all right, they'll give you question 1, and you'll be able to read the question and answer in some way. So just to recap, at 1:30, you guys should be logging in. At 2 o'clock, the first question is going to appear, and for 25 minutes, that question is going to be open, all right? It'll be open for you to evaluate. And then, after you submit your response, 5 minutes, you get a little bit of wait time, 5 minutes, and then question 2 is going to appear. And then you get 15 minutes to work on question 2, and then you submit your response, and then the exam is over. So it's gonna be quick, y'all. It's gonna be quick. Don't care. Okay, do your best to test by yourself in a quiet room. Yeah, remove distractions, put do not disturb on your cell phone, whatever. Let your siblings, let's just focus on that. Let your siblings know when you'll be testing so they'll leave you the heck alone. Make sure your device is plugged in. If you have limited bandwidth, which is what has been an issue here at my house, that's why I keep telling my wife, can you go somewhere else? can you take a break on teaching and go read a book for a little while? Because if you have limited bandwidth, ask other people to stay off of it, because that can mess you up. Now, this is hilarious. Who knew in 2020 Fortnite would be referenced in an official AP document? So if you have a little kid that's in your house playing Fortnite religiously in 2020, which would be weird, tell them to take a break for 45 minutes so you can do what you need to do and have everything with you. Okay, here we go. This is important. You may not incorporate work which is not your own. You may not provide or receive aid of any kind from anyone. To identify students attempting to receive help through the web, a phone, or social media, sophisticated detection technologies and processes will be applied. Most techniques will remain confidential to maximize their effectiveness. We will be monitoring social media and discussion sites to detect and disrupt cheating. We may post content designed to confuse and deter those who may attempt to cheat. Attempts to cheat will be detected immediately during testing or will be identified in June and July simultaneously with exam scoring. In addition, students' exams will be scanned by plagiarism detection software and shared directly with their teachers. So I'll get to see all your stuff. And if I look and I'm like, man, Emily and Lauren's answers look exactly the same. Yeah, I'll be able to tell. Not to call you two out, it's just you were the first two in the chat. Students found violating exam security will face severe consequences, including having their names reported to college admissions offices for attempted cheating and having your AP exam scores canceled. This is some serious stuff, y'all. So for more, there you go. Check-in time. You type in your AP ID so you can access the exam. You'll have a timer on screen that'll tell you how long you have. And then when that timer's over, that's when the first exam question will appear. So for answering the questions, it'll be divided into parts. Okay, so for most exams, and you guys know this with AP Chemistry because we've done free response questions. If they have like parts A and B, make sure you label them A and B. And by the way, not to call out anyone in particular, and I'm not going to say who it is, but there's one of you that I feel like this is worth mentioning. When you guys are doing your handwritten responses, okay, it is crucial that if you are showing, like if it's a math question, for instance, you have got to show your method. You can't just go in, write down 2 or 3 numbers, and then a final number and be like, yeah, they can probably figure out what the right answer is. You've got to explain yourself. And I know that time is valuable and you don't have a lot of it, but it can be really easy. Just write like, I'm going to use this equation. And then say, this equation will be used to find the entropy, period. That's all it takes. Just one little brief statement, and that could be the difference between a 3 and a 4 or a 4 and a 5. It's just you explaining yourself. So make sure you do that. You may use spell check and grammar check, but these will not provide an advantage. If you'd install Grammarly, disable it. You guys know they're not testing you based on grammar. They're basing you on chemistry. You may print the test questions and annotate them if you want, but you can't use annotation software online. Exams with more than one question, you will not be able to move on to the second question until the test says you're done with the first one. Once the time for the first question is finished, the second question will appear, and you can't go back once you click submit. So basically, guys, just focus on question 1. After you're done with that, focus on question 2. That is the best way to use your time. Speaking of which, you can see they'll have timers. Okay, it'll remind you to stop and submit your response. Okay, and it'll show you where you're supposed to copy and paste and click submit. You can still earn a 5 even if you don't finish. Okay, but if you don't submit anything, you don't get anything. Okay, and not to put extra stress on you guys, but if you have a minute left and they're like, you have 1 minute left to submit work, go ahead and submit. And here's why. If all of a sudden bandwidth issues become a problem and you're in the middle of submitting and it's uploading and 30 seconds are left and it's still uploading and then 5 seconds are left and it's still uploading, you do not want to be in that situation. So what I'm telling you to do is just go ahead and assume that you have 24 minutes and 14 minutes, and that way you can make sure you get your work turned in. Blah, 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 submit. We've already talked about it. You attach it, and then you click submit, all right? Once you click submit, your response may continue. That is fine. You will be able, as long as you click submit before the time ran out, they say, but I don't know. You guys do what you want. I know what I would do. That's all I'll say. What could go wrong? If you accidentally close it, that's okay. Just click the exam e-ticket so you can get back in. Not a huge issue. If you feel like at the end, like if maybe for whatever reason, I don't know, your laptop starts smoking, okay, and it just shuts off completely. That would obviously be something that you could request help with. Take a picture of it with your phone, document it, say what happened, and then you can submit information there. Do not call anybody, okay? Don't call. That's not going to do anything. Exam scores. Yeah, I don't want to talk about that. I'm not going to talk about that. No, you guys can read about this on your own. So anyway, that's that. This is something you guys need to print out. You need to print this out or put it somewhere so that you have it. This is what you need to have done for each AP exam. You need to have one for AP Chemistry. You need to have one for AP Government. You need to have one for AP US. It's going to be a separate checklist for everything. Okay? And go through what it tells you. Go through what it tells you and make sure that you've done what you need to do. Please, please do that. Do not wait until the day of and be like, well, I guess I better do that checklist. Because by that time, if you have a computer issue, no one is going to be able to help you. So do it ahead of time. Do it on Monday, all right, as much as you can. So AP exam checklist, it's in the AP chemistry. Is this it? Is this it? Yeah. Here we go. There you go. See, you got it. And it's in OneNote. So do what you need to do. All right, I'm done talking about that. I'm done talking about that. I'm live streaming, and there are 5 people here. Are there any questions before we move on to the next part? I'm going to reply to this email real quick because there's a 30-second delay between when I ask something and when you guys hear it. So if you have a question, please let me know. Any questions? Otherwise, thumbs up emoji if you're good. If you're like, yeah, I got this. Is this a dab emoji? Why on earth would I need that? What is that? Peace sign? I don't know what that means. Ooh, they have a hand sanitizer one. Hand sanitizer, cat. Stop. There you go. All right, guys, we're going to go ahead and get going. Since no one seems to have any questions. All right. Let's see if what I prepared ahead of time will be ready. Is there anything that I can go over that can help you guys? Because you guys asked for this. Yeah, there you go. Give me a dab. Perfect. Is there anything I can help you guys with? Y'all called the meeting. So if there's anything I can go over, I'm going to do the best I can with it, even though it's a little rusty. I hope that me going over the AP exam stuff was helpful. I hope. Is that a peace symbol? What else have I got? Food. I want food. Oh, here we go. Food. Okay, well, show me the food emojis. Why are the emojis not working? All right, guys, come on. What questions you got? Let's get serious. All 4 or 5 of you. 4 of you. So I guess somebody just wanted that. This part of the unit in general was rough, so just go over the problems. You got it. All right, 7B. One thing to keep in mind, guys, is KSP, similar to just K, is it still has to do with equilibrium. It's just that when you're talking about KSP, this is basically an equilibrium state between your solid substance and then that substance in ion form. Okay, the ions of that substance. So when you're dealing with KSP, just know that's what's going on. Okay, so problem number 1. Yeah, if we can go over problem number 1, I think that'll be a good place to start. This one is actually an ice table, which is something that I tried to go over, and I was fully ready to go over a week ago, and then the internet decided, no, I'm going to give you a hard time. But now I'm good. Nobody's even here. It's just me. And so you guys should be able to, we shouldn't have any issues with internet like we did last time. The only issues we'll have is with your incompetent teacher. All right, number 1. Solubility of A2B3 is X moles per liter. Its KSP is what? And they want to know. So this is an ice table problem. And in case you've forgotten, an ice table is where you start by just writing out the full balanced equation. Great, I immediately get a working offline error. It doesn't look like it because it's loading as I wrote it. So always start by writing out what you have. I can do reverse swap and drop to figure out that the charge on A was a +3. The reason I know that is because it was the cation, it was listed first. You can reverse swap and drop and find out that it was a +3 charge. And we're going to go ahead and say this is the aqueous state. In fact, let's go ahead and say this over here was the solid state because it is. Okay. And then for B, we're going to do the same thing. I'm going to assume that's the anion because it was the second one listed. And so after we get all this, we can balance it really quickly with a 2 and a 3. Wow, that was difficult. Now, that's the easy part, figuring out what the balanced chemical equation should be. The next part is doing the ice table. Now, if you've forgotten, okay, which I know it's been a while, ice stands for initial, change, and equilibrium. So you always start by saying, all right, what are my initial concentrations? Okay, what is the initial whatever? And then what is going to be the equilibrium state? Now, because A2B3 is a solid, okay, it's not really going to have a concentration. Does that make sense? Hopefully. Because if it's a solid, that's not what we're dealing with. We're only going to have concentrations of your A+3 ions and your B2- ions. So we're only going to focus on that side. Now, so initial, I'm just going to put a line there because it's Na. We don't care. But for A and for B ions separately, we do care. We do need to know something. Now, if we're assuming that we start with solid, it's 100% solid, and we start with pure water, then my initial concentration of A is going to be 0. My initial concentration of B is also going to be 0. Okay? The reaction hasn't started yet. It hasn't started to dissolve, and so they're both going to be 0. But now, we have to look at this in terms of stoichiometry. We have to look at this in terms of moles of something versus moles of something else. So for A right here, we can see that it has 2. So as 1 mole of this dissolves, it will form 2 moles of A ions. I'm going to say that again. For 1 mole of A2B3, 3 moles of B2- ions are going to be formed. And so what that means is for every 1 mole of this that goes away, we'll get 2 of these and 3 of these. And so this is when we represent this with an X. So the change in my A ions is going to be 2X. The change in my B ions is going to be 3X. All right? And so what that means then is that at equilibrium, we will have 2X concentration of A, and we're going to have 3X concentration of B. All right? Okay. I really wish that you guys were here so I could see your faces. I don't think you guys realize when we're teaching in class, usually by looking at you, I get an idea of, okay, did they really get this or not? So if you guys need me to slow down and re-explain something, you have to communicate to me. Because right now, all I can see is a pink silhouette, a green silhouette, a beach maybe. I don't know what Kira's is. It's too small. All right. So at this point then, this is when we can write our K, equilibrium statement, basically. Now, because we're dealing with KSP, I'll go ahead and specify that it is KSP, but it's still going to be products over reactants. Products over reactants, products over reactants, coefficients become exponents. It's the same thing that we've been doing for over a month now. But now it's KSP. We're dealing with the same thing, it's just dissolving. So, obviously, reactants are not going to be included in this statement at all. Solids are not included in equilibrium statements. And so instead, we're just going to have basically concentration of A times concentration of B. Concentration of A is going to be squared because it has a 2, which we can see right here. B is going to be cubed because, as we can see, we have a 3 coefficient right here. And now we got to plug stuff in. And so that's where this comes in, these values down here at the bottom. Because that's it. That's the concentration, okay, at this. And as you can see, all of our answers are in terms of X. So we're not going to get a fully numerical value for KSP. Instead, we're just going to get something in terms of X. That's all we're doing. So I'm going to plug in some numbers, do some quick math algebra. We're going to see what we have. So concentration of A at equilibrium is 2x, which we can see right there. It's going to be squared, times B is going to be 3x cubed. All righty. And so what we end up getting then is we say, all right, well, KSP then is going to be equal to 4x squared times, not 20, not 9, 27 x cubed. Yeah, I had to double check that math. This was a long time ago, so I'm trying to remember what I said. So KSP is going to be equal to 108x to the 5th because math. There you go. Answer D. All right, let's move on to number 2. Because this one's kind of weird. This one's kind of weird. Trying to remember why I wrote 0.1 there. I don't think that was a typo. Solubility of silver iodide in 0.05 molar barium iodide solution is 1.0 times 10 to the negative 15th molar. Calculate the solubility of AgI in water. All right, so we're doing a bunch of junk. And in fact, my wife and I both looked at this one, and I remember we finished by putting a question mark next to it. So I'm going to go over it the best I can, and that's going to be good enough. All right. So first things first, it's helpful to go ahead and write out these equations. So that's what I'm going to do. Starting with this barium iodide, because we're talking about barium iodide solid is going to, I don't need to put that, I don't need to make an equilibrium. Is going to become Ba2 plus aqueous plus 2 iodide ions. Okay, so there's that. And so we know we're dealing with a 0.05 molar solution. Now what that means is I'm going to have 0.05 molar Ba2 plus, but because there are 2 I ions, for one of those is going to be 0.1 molar. Okay. Let me explain that a little bit better. So basically, when we're talking about a solution, sorry, Burleson sent me an email finally. What was I talking about? Oh yeah. So because barium iodide is all one thing, you would say, oh, well then if it's in a 0.05 molar solution, then that means 0.05 moles of barium iodide and 1 liter of solution. You guys understand that. But the thing is, it's a 1-to-1 ratio between barium iodide and barium ions, but it's a 1-to-2 ratio between barium iodide and the iodide ions separately. So basically, because of that 2 right there, we can assume that for every 1 barium, we're going to have 2 of those. And so that's why that one becomes 0.1 molar. It's going to be important later, so just kind of hold on to that. Now, for AgI, we know that its solubility is going to be, let's see, let me get caught up real quick. We know that its solubility in this barium iodide solution is going to be 1.0 times 10 to the negative 15th, which means that's not a lot of solubility. And the concentrations over on the other side are going to be the exact same thing because look, it's a 1-to-1. See, it's 1 mole of this for every 1 mole of this. It's 1 mole of Ag for every 1 mole of iodide. Iodide. And so this is still going to be 1.0 times 10 to the negative 15th molar. This is still going to be 1.0 times 10 to the negative 15th molar. Okay? And so based on that then, let me make sure I know what I'm talking about. Yeah, I still don't like this problem, and my wife and I didn't like it either. But basically what this ends up telling us then is in water, originally, if it were pure water, even without the barium iodide in it, it would just be pure water. But once you dissolve barium iodide in it, we end up getting this 0.1 molar of iodide ions in solution. So think about it this way. If you're dealing with limited solubility, which we are for Ag iodide, silver iodide, then we can use the solubility of barium iodide to tell us what it's going to be like when we dissolve AgI in pure water. So let me say that again without distraction. Sorry. I got a text message and an email at the same time, and it's very distracting. Don't do that on test day. So basically, you start with pure water. As soon as you dissolve something in it, it's not water anymore. Now you're calling it a solution of something. So if you put barium iodide in it, we can say, oh, well, then it's going to be 0.05 molar. But again, it's 0.05 molar barium iodide. It's 0.1 molar iodide ion solution. So even though you're saying it's 0.05 molar barium iodide, but if you're looking at it in terms of just the iodide ions, it's going to be 0.1 molar. Because as we can see, you get 2 for every 1 barium iodide. And so because that's the common ion in both, we can see that we have an I and AgI. We can see that we have an I and I2. Because that's the common ion in both, that's the link. That's how we can find out something about the solubility of AgI in pure water. And so the thing is, if we're saying, okay, well, 0.1 molar ends up being the solubility, that ends up being the concentration of the iodide ions, then we can say something similar about it in AgI. See how little of this dissolved? See, if you're trying to dissolve silver iodide, see how little of that dissolved? We're talking 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 1, I think, molar. That is a massive difference. So what that means is the iodide ions are already dissolved as much as they're going to be in pure water. And so what that means then is this is basically the maximum. 0.1 is the maximum amount of solubility that you're going to get in pure water. And so, because that's the common ion, we can assume then that in pure water, in fact, I'm going to write out my words so it makes a little more sense. In pure H2O, okay, I minus ions, oops, that was a bad cue, are limited to 0.1 molar, concentration solubility. That's as much of it as you're going to get dissolved in pure water. And so if we look at the silver iodide solution, we can see, oh, for every 1 molar of I2, I get 1 molar of AgI. And so because it's 1 to 1, we can say, oh, well then if in pure H2O, iodine is only going to be limited to 0.1, then that means that AgI is going to be limited to 0.1. And the reason I'm saying limited is because even though we're adding more iodide ions into solution, even though we're trying to dissolve more silver iodide, it's not dissolving anymore. Okay, not really. 1 times 10 to the negative 15th molar, I'm going to go ahead and say that's not dissolving very well at all. And so that's why we're going to say, oh, well then in pure H2O then, in fact, I'm going to write a therefore statement. It's been a while since we had one of those. Therefore, silver iodide will only dissolve up to a concentration of I equal to 0.1 molar. And because it's 1 to 1, 1 mole of AgI for every 1 mole of iodine, so that means therefore, the solubility of AgI is going to be equal to 0.1 molar also in pure H2O. Okay, so that's my thought process there. All right, there's a lot of talking. Let me read this text message real quick and get a drink of water. Excuse me. I know that's rude. Okay. Number 3, salts. M2X, QY2, and PZ3 have the same solubilities. And so we're trying to relate their KSP values. So something that my wife did is that she wrote it all out in terms of the equations again. So she's still writing these equilibrium statements. And in fact, we ended up making an answer because we didn't think it was A, B, C, or D. You guys let me know in the comments if you thought it was one of these, and you can try and explain why. But my wife and I made a new answer. All right. Just to make things a little bit easier for you, I'm going to break this down a little bit more simply. Okay, they have the same solubilities. Keep that in mind. All right, so I actually am going to do it my wife's way in terms of writing things out. So hopefully it'll make a little more sense to you guys. But again, just letting you know, the answer is going to be answer choice E, which I'll talk more about here in a second. All right, so let's start with the first one. M2X. Please load OneNote. Don't be stupid. Hopefully it'll load here in a second. M2X. Okay, its solubility is going to look like this. 2 M pluses plus 1 X minus 2. All right? That makes sense, hopefully. Let's look at the next one. QY. Okay, this one is going to become a Q plus 2 ion plus 2 Y minus ions. Okay, so there's that one. Then the last one, PZ3. PZ3 is going to look like this. We're going to have 1 P plus 3 ion plus 3 Z minus, whoa, there we go, Z minus ions. All right. Now for each of these, let me move this out of the way. This is in the way. There we go. Just need that out of my way. Let's start back and start writing our KSP equation, statement, whatever you want to call it. So KSP for this, which remember, everything in the left-hand column is going to be a solid. So everything over here is going to be a solid. So therefore, it is not going to be included in our KSP statement. Remember, it's products of reactants, but solids never go into it. All right, so all those are going to be solids. Everything over here is going to be AQ, and so therefore it will be included in our KSP statement. So just going to go ahead and get that out there. So products of reactants, and my products are going to be, well, it's going to be M plus squared, and we know that because it has a 2 in front of it, times X to the minus 2 with nothing. All right, with nothing. Next one. Next one. Do an orange. Keep my theme consistent. Here's KSP. This is going to be Q with a plus 2, just like that, with nothing. But then we're going to have Y to the minus square, just like that. And so I can stop right here and show you guys really quick that based on this, if their solubilities are going to be the same, that means they're dissolving similarly, okay? That means their concentrations at equilibrium. Again, I know I'm saying equilibrium here, but remember, what I mean is the equilibrium state between solid, solute, and dissolved ions. So it's still equilibrium, it's just a specific type. So they're all going to dissolve at the same amount. So really what we're looking at here is just algebraically, how are the KSPs going to be related? And for both of these, we have one term that is squared. See, this one is squared, this one is squared. And we have another term that is not squared. And so technically, if you think about it just mathematically based on that, the two of these are going to end up being equal. So both of these are going to be equal to one another. But now we get to PZ3. So for my last one, we'll look at its KSP as well. We can see we're going to have P plus 3. That's all fine and dandy. But then we're going to have Z minus to the third. And so if you look at this algebraically, you can see, okay, one of them is still not squared at all. That's the same as the previous one. See, not squared, not squared, not squared. All of those were all just to the 1. But now this one is cubed. And so this one is going to be greater than the previous ones. This is going to be the biggest one. And so based on that thought process, that's why my wife and I made up answer choice E, because we thought it was better. We said that KSP of M2X was definitely going to be equal to KSP of QY2. Well, that is some bad handwriting. Sorry, guys. And we said that both of those, while they're equal to one another, are still going to be less than my KSP for PZ3. So we made up an answer for that one. If you don't like it, sorry, that's it. So we looked, I double checked where I got it from, this question, and that I didn't do a typo. Like I typed it exactly the way they did, but my wife and I believe that the textbook made a typo. We think this is the correct answer. Prove me wrong. Okay, so if you have a different response in the comments and you think your answer is better, please explain why you think your answer is right. Let's take a look at number 4 in the meantime. Okay, number 4. KSP of lead bromide is 8.0 times 10 to the negative fifth. If the salt is 80% dissociated in solution, calculate the molar solubility of the salt. All right, so this one's kind of funky. It's best if you look at it in terms of an ice table, so similar to before. I'm going to go ahead and start by writing out my balanced statement, okay, my balanced chemical formula. And I don't think I need to go over this, like how you get this formula. I don't think I need to go over that. Hold on, Lauren. I'm reading your answer and thinking about it. But the thing is, if you do 3 times, see, that 427 refers to everything in the solid column. So everything, sorry, I'm trying not to make this more confusing. Everything in this column right here would be that 427's value. But the thing is, because that's 427, like over here, this 3, for instance, that's going to be 3 times 427. So that means the value is still going to be bigger. Oh, but the solubility is still less than 1, even if you do 4 times 1. I see. I mean, the answer is A. Dang it. Now listen, before you start judging, judgy McJudge faces out there. This was probably 10:30 at night, and my wife and I have been doing this for too long, and we both got tired. So it's possible we made a mistake. So don't add us. But yeah, it's looking like the correct answer choice is A. Dang, you're right, because it's a fraction. If you cube a fraction, that just makes it smaller and smaller and smaller. Daggone. Okay, good job, Lauren. Gold star. Is that an emoji? An emoji? Gold. Let me look at star. Seriously, no emoji? All I have access to are the YouTube emojis? Okay, well, I'm going to give you this instead. I don't know what that means, but I'll give you that instead. So yeah, you're right. So what she's saying, guys, if you imagine, let's just look at the yellow one, for instance. If you imagine going in and putting 427 or 4 over 27 in each of these, that ends up being a very small value. And then that other one would technically be 12 over 27, because it's 3 times, because it's a 3 to 1 ratio. It would still end up being less than 1. And so, yeah, that would be not much bigger. That'd be much smaller. So shoot, that's our fault. Okay, good job. Let's focus on number 4. Okay, where was I? Oh, ice table. So let's look at this. ICE. Initial. It's usually going to look something like that when you're doing these types of problems, because initially we know that this over here is a solid, so we don't really care about its concentration. That's why it goes flat. It's 0 to nothing, Na. We don't count it. We don't care. But it's 0 for each of these over here that are both going to be aqueous, because initially we're assuming they have nothing. Okay, now, based on that then, we have to use the stoichiometry to tell us about what's going to be changing. Again, you think about it in terms of, okay, if 1 mole of lead bromide is dissolved, you're going to get an increase in positive X, 1 mole, whatever, of lead, but you're going to have an increase of 2X of the 2Br, because again, it's a 2 to 1 ratio. So you use the stoichiometry to help you. And again, we don't really care about the change in that. That doesn't matter. We're looking for the solubility. All right. So what that means then is that at equilibrium, this is going to be x, this is going to be 2x. And so now we can look at it in terms of KSP, which is pretty helpful. So now it's just the same as, not the same, but it's similar to problems we've done before. Because they gave us the KSP value over here, we can just do some math to figure out what x is going to be equal to. And because here's the thing, if we find out what x is equal to, because it is a 1-to-1 ratio of lead ions to lead bromide, then that's going to tell us the solubility of the whole salt, the salt as a whole. So we need to just solve for x, basically. So if we write out our KSP statement, which I'm going to do over here, KSP is going to be equal to that times that, right? Products over reactants. Products over reactants. So it's still going to be that. No reactants are included because it's a solid, just like normal. Now we plug in our algebra. Okay, just like that. So we end up getting, and we can also plug in, what KSP is equal to, because the problem gives it to us. So it's going to be 8.0 times 10 to the negative fifth. All right, so there's my KSP value. So now we're just solving for x. This is going to end up equaling x times, not a 2, 4x squared. So that means it ends up becoming 4x cubed. Okay, so there you go. It's 4x cubed. I know it's off the edge of the screen over there. There we go. And so, yeah, we just do math. Dot, 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 algebra happens. X equals 0.027 molar. That's what we got. Okay, there you go. Math happened. Okay, let's take a look at number 5. Solubility of silver chromate, which they give us the KSP for it, is determined in 3 solvents. We need to predict the relative solubility of this in each of these 3 solvents. What we're going to be looking for is the common ion in each of these. The common ion in each of these. So silver chromate has no common ions with part A. Okay, has no common ions in part A. So when it dissolves in water, it's just going to be what it's going to be. Gosh, do I have to do an ice table for all of these? I'm going to... Dang, it's... All right, it's going to be okay. Good thing I have so much room to write. Let's take a look at just regular old, the regular old formula, just so we can have it in our head. So Ag2Cr04 is going to become 2Ag plus Cr04 with a 2 minus. All right, so there we go. There's our regular equation. So one thing that I want to point out is one thing that I'm noticing is we have 2 silver ions and we only have 1 chromate ion. That's going to be important here in a second. Because if you think about it in terms of common ions, we can see that in part B, the 0.1 molar silver nitrate, because it's trying to add even more silver ions, I can go ahead and say it's probably going to be much less soluble in B than it would A. So, in fact, you know what? Without even writing anything down, let me make sure I'm right. Disagree. Yeah, B is going to be least. Yeah. Without even writing any math down, because I'm afraid it's going to confuse you guys, here's my thought process. If you think about it in pure water, there's no ions in solution yet. There's no ions that are in solution yet because it's pure water. And so that means there's plenty of room for both ions. There's plenty of room for your Ag plus and your CrO4 2 minus. That's an H2O. Now let's think about it in terms of your Ag. Guys, I'll be right back. Give me 1 second. Sorry about that, guys. How unprofessional of me. So what I'm saying is, if we look at it in terms of water, there's plenty of room for everything. And so that's why I'm going to go ahead and say that it's going to be the most soluble here. This is going to be the most soluble because there's plenty of room for everything. It's clean water. There's not anything dissolved. But if we look at it in the AgNO3, okay, look, there's already Ag ions present. It already has Ag ions present. And yes, it has nitrate ions too. I don't really care because it's not bringing any nitrate ions to the party anyway. It's bringing chromate ions to the party. So it already has Ag ions. So what that means is there's less room for new Ag ions. And also remember, for every 1 mole of silver chromate, there are 2 moles, okay, 2 moles of silver ions, okay? Now let's look at the last one. Because for the last one, if we're looking at it in this sodium chromate solution, this already has these chromate ions in solution. So what does that mean? There's less room, okay? It's going to quickly reach equilibrium. When I say room, what that means is it's already close to equilibrium for that ion. And so it's either going to reach equilibrium very quickly, so it's not going to dissolve more of it. And that's why I think about it in terms of room. If you want to think about it in terms of equilibrium, like a real chemistry person, you can. But that's really what I'm thinking here. So there's less room. There's already chromate ions that are dissolved in solution. And so then you've got to say, okay, well, we know that water is going to be the most soluble. In fact, so that means that we can already isolate answer choice C or D. We know it's going to be C or D because A has the greatest solubility. But from there, then you've got to say, okay, well, what is it going to be? Silver nitrate, or is it going to be the sodium chromate that's going to be more soluble? And the answer is this is going to be slightly more soluble, and this is going to be slightly less soluble. And again, the reason is it goes back to the fact that there are 2 silver ions in silver chromate, and there's only 1 ion of chromate. Sorry, 1 mole of chromate ions. And so because of that, yeah, there's already some CrO4 that's in solution, but it's not bringing that much more CrO4. It is a little bit. But in terms of silver nitrate, there's already silver ions. This is bugging me, Ag plus ions. And so there's less room for silver, and it's trying to bring in 2 moles of it at a time. And so that's why. So the answer here, the answer choice D. And that's my hand-wavy way of explaining it to you all. My wife was wanting to go through this really complicated thing where you do an ice table for every single one of them. Kira, I'm not sure I understand your statement. But if you guys want me to explain it that way, I can, but I think that's going to make you more confused than my way of explaining it. Oh, okay, Kira, I'm sorry it's taken so long. Have a good day. Let's look at number 6. 3 sparingly soluble salts, so that means they're not highly soluble, are M2X, MX, and MX3. I'm sure we won't get confused at all. Have the same solubility product. Their solubilities will be in what order? Once again, it's helpful to look at this in terms of their reaction formulas, okay? So if we look at it like this, we'll start with M2X just to give you an idea of what I'm looking for. So this is going to become 2 M pluses plus 1 X2 minus ion. Next, we can look at MX. This is going to become 1M plus 1X. Not really confusing. And then now we're also going to look at MX3. So if we look at MX3, we can see we're going to end up getting an M with a 3 plus 3 X minuses. That looks just like that. And so you get to say, okay, well, what's going to be the most soluble? What's going to be the least soluble? Think about it in terms of ions. Which one is going to separate into more junk? Okay, look at it. So in M2X, we can see that over here we have 3 ions that form from this one solid over on the left side. And the next one, we can see that in 1 mole of MX, we end up getting only 2 ions. So basically it breaks up into 2 moles of substance. And in the last one, MX3, we end up getting 4 ions over here on this side out of 1 mole of stuff. And so what that means then, answer choice B is the correct answer. Okay? It's going to be the correct answer because you're going to get a lot more stuff getting dissolved in this third one than you do in the other two. Okay? And then obviously, that's why this one's next. That's why this one's last. All right? So anyway, look at number 7. Solubilities of silver chloride in water and in 0.01 calcium chloride, 0.01 molar sodium chloride, and 0.05 molar silver nitrate are S1, S2, and S3 and S4 respectively. Select the correct relationship between these quantities. Okay. Sorry, I'm getting my mess together. So we can see common ions again here, and that's the way you've got to think about it. Because basically your common ions are going to decrease the solubility, just like what we were talking about before. Back when I was looking at this problem here, I was really looking for common ions. There were no common ions in H2O. There was a couple of common ions here. There were several common ions here, and that's why I decided what I decided. So in number 7, we're going to do something similar. Let's start by looking at just the basic equation. So we have AgCl. And it's going to become Ag plus Cl minus. So there we go. There's our basic equation. But now we've got to look at these in terms of common ions. All right, so CaCl2. Can I move that over? Sorry. Move that over just a little bit. So in terms of common ions then, we can say, all right, well, CaCl2 is going to end up becoming Ca2 plus 2 Cl minus. Okay, and next one, this will make sense in a moment. We want to look at is NaCl. NaCl is going to decay into Na plus Cl minus. And then finally, we get to 0.05 molar. Notice that's 0.05. They changed a little bit. That means it's more. All right, that's already dissolved. But in the last one over here, this is going to decay into Ag plus NO3 minus. Now, let's look at this in terms of the common ions that we have. Because if we look back at our original equation, AgCl becomes Ag plus Cl minus. So our common ion in the first one, calcium chloride, is going to be the chloride. So that means you're going to end up having an increase of 3x Cl. You're going to have an increase of 3x Cl because you're bringing 1 from the original equation. You already have 2 that are dissolved in solution. All right, so think about it that way. Now let's look at orange. Let's look at the NaCl. In this one, you're going to have an increase of 2x Cl. Okay, you're going to have an increase of 2x Cl because you're bringing 1. There's already 1 in solution. Okay, so right away, we can kind of suss this out. We can decide, okay, S2 and S3, which, by the way, pure water is S1. This is S2. This is going to be my S3. And then S4, I'll go ahead and talk about real quick. Our common ion is not chlorine anymore. Chloride. Our common ion is now silver. And so over here, it's going to be 2x Ag plus because, again, we're bringing 1 Ag from the Ag chloride, silver chloride, excuse me. There's already 1 silver ion we're getting from the silver nitrate, so it's going to be an increase of 2x Ag over here. So this is going to be my S4 over there. So my answer, which I'm going to go ahead and just tell you what it is, and then I'll explain a little bit better, is going to be C. Okay, because what we can see is that S3 has the least common ions. And before you say, but Mr. Nairn, that one has a 2. That has an increase. That has 2x ions in it. And this has 2x ions in it. But remember, this is only 0.01 molar. This is 0.05 molar. So it's a heavier concentration. So even though we're dealing with the same amount of ions in terms of moles, this has more moles dissolved in it because of the higher concentration. And so that's why we can decide between S3 and S4. All right. Yeah. And then next we can go to this. This one is going to be the least soluble. Is that what I want? Nope. What did I say S4 is mine? Sorry, now I'm getting my words all confused. Common ions decrease the solubility. So S3 has the least common ions. Yeah. Let me write it out so it makes more sense to me. S3 is the least common ions other than water. So first we have water. That's going to be the greatest solubility. S3 has the least common ions other than water. And then we're going to have S2, which has, this one has more common ions. But because S4 has that so much higher concentration of 0.05 molar, this has the most common ions already. And the reason we're looking at this in terms of common ions, guys, is because, again, you've got to think about it as, okay, if this already has a lot of something dissolved, it's already close to equilibrium, and so the solubility is not going to be that much more. Okay, so I like to think about it in terms of space, available space. So if you already have a lot of silver ions in solution, which we do, 0.05 molar, and you're trying to bring more silver in, there's already not any room. They're like, sorry, we're already full. And so it reaches equilibrium very quickly. Once it reaches that equilibrium concentration, you're not going to dissolve any extra silver ions. So anyway, that's my reasoning for number 7. Sorry, that got kind of confusing. I know you guys are feeling the pain. And I know you're probably saying right now to yourself, well, yeah, this whole thing's been confusing. Let's look at number 8. This one's not that bad. It's really not that bad. So we're looking for KSP in this problem for number 8. That's really what we're looking for. They gave us the solubility, so they're giving us X. And so once again, ice tables. We got to do an ice table. It's going to be great. So first things first, we need to write out our equation. We have A2B3. This is going to be in equilibrium with 2A3 plus ions plus 3B2 minus ions. Okay, once again, I'm going to write ICE, initial change equilibrium. And because A2B3 is the solid, it's a salt. Okay, it's a solid salt. We just don't really care. We don't care about its initial. We don't care about its change. We don't care about its equilibrium. We could give a crap. So instead, we're going to look over here at A. Initially, these are both going to be 0, just like we've done in the past. But now we've got to look at it in terms of change. For every 1 mole of salt, for every 1 gram of salt, for every 1 whatever salt, we're going to see an increase of 2x for A. Again, it's based on the coefficient in front of A in the balanced chemical equation. And we're going to see a plus 3x in B. Same reason, because of the coefficient. So that means that at equilibrium, this is going to be 2x, this is going to be 3x. And so now what are we going to do? Well, we are going to look at the KSP formula, which, by the way, X does have a value. They gave it to us. They told us that the solubility of A2B3 is 1 times 10 to the negative 4th. So what that means is if you wanted to write it this way, you could think about it as saying, oh, well, this decreased by negative X of whatever it was. You can think about it that way if you want. I just normally would just rather say Na. But because they give us the solubility, that means that X is equal to 1.0 times 10 to the negative 4th. Okay, they're giving it to us. And it is molar. I'm not sure why I didn't type the units in. Maybe that was my mistake. Maybe that was the book's mistake. But that molar should go there. All right, so now that we know X, we're looking for KSP. Let's write out that formula. KSP is going to be equal to concentration of A to the 3 plus squared times B2 minus to the 3rd. Okay, so we're looking at this. We're looking for KSP, so I'm just going to rewrite. And we know some numbers. Okay, we could plug in X if we wanted to, if this makes you guys feel better. So this is going to be 2x squared times 3x to the third, okay, just like this. And honestly, guys, you're plugging in x as that 1.0 value, and math happens. So I'm not going to waste our time with that. I'm just going to say math happens, dot, dot, dot. I ended up getting a KSP equal to 1.1 times 10 to the negative 18th is what I got. So there you go. Okay, I'm going to keep on rolling because time is short, and you guys are probably already tired of listening to me talk. It's been a while. So let's take a look at number 9. Value of KSP of mercury chloride is 4.0 times 10 to the negative 15th. The molar concentration of Cl minus ion in its aqueous solution at saturation point is what? Well, let's look at the ice table. That's going to be better. Saturation point is going to be equilibrium. Saturation point is just another way of saying equilibrium. Saturation point is going to vary based on temperature. Not like we care, but I'm just telling you that. So let's take a look at this. As always, I'm going to start with my balanced chemical formula because that's what the ice table is made from. Okay, so I'm going to end up having Ag2 plus 2Cl minus ICE. Dash, 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 because we don't care. It's the solid. I could care less. Hg initially is going to be 0. Cl going to be 0 initially. Once again, we use the coefficients to help us understand what the change is going to be. So for every 1 mole of HgCl2, we see an increase of plus 1x of Hg and plus 2x for Cl. So that means that at equilibrium, we'll have x and we will have 2x. All right, guys, I'm going to drink some water really quick. People we got. I have a feeling a lot of you left. Okay, just Kira. Tell me how you're feeling about ice tables, just ice tables specifically. You can see the problems have an emphasis on that. I'm going to put an emphasis on that. But how do you feel about ice tables from 1 to 5? 1 being I'm completely confused. 5, they're not that difficult. Okay, now that I've gone over a few of them, at least to this point. 1 through 5, how you feel about ice tables. 1, they're very difficult. 5, they're perfect. Try and drink a little more quietly. Check this email real quick. $4.5, I can handle that. Anybody else? I am really interested. This is the best way. Yeah, okay. I'll touch on that in a second. Anybody else? This is the only way I have to assess how well you guys get it. I'm sorry. This is the best that we can do in these circumstances. 4, good. Good. Emily, the way that I know to use them is whenever I'm dealing with a problem where they either give me KSP, okay, and they're looking for concentration, or they give me one of the concentrations and I know I'm looking for KSP, this is the best way to do it. This is the best way to break it down and try and figure out, okay, what is actually changing, by how much. So basically, I'm looking at the problems, and if you look back, not just on the 7B problems, but the 7A problems that I attempted to go over with my limited internet issues that I had last week before, whenever that was. They're all written basically the same way. They're either giving you molar concentration of something and they want KSP, or you have KSP and you're looking for the molar concentration of something. They're all written the same way. So that's kind of how I know when to use them. Okay, I don't know who our anonymous 4th person is that's watching, but thank the 3 of you for answering. Let's go ahead and look at the next part. So now that we've gotten this far, now that we have our nice ice table written out and everything, we've got to use it. They gave us a KSP value, but I'm going to go ahead and write out the KSP statement so you guys understand. Remember, it's just like doing any other K statement, products of reactants. So KSP is going to be equal to Hg2 plus times Cl minus squared. So that's what we're dealing with. But now we know that at equilibrium, it's going to be x and 2x. So we're just going to plug stuff in because we have the KSP value. It's this 4 value, 4 times 10 to the negative 15. I'll scroll over a little bit. Whoa, not that much. Okay, let's try that again. Let's get over just a little bit so I can plug in some numbers. 4.0 times 10 to the negative 15th is going to be equal to, not hg anymore, now it's going to be x. Now it's going to be 2x squared. And so obviously, you guys can see where this is going. Math is going to happen. So basically, this ends up equaling 4x cubed. So obviously, you divide both sides by 4, divide by 4. Then you do the cube root, okay, of both. All right, but anyway, math. And I ended up getting x is equal to 1.0 times 10 to the negative 5th. Okay, molar. That is not the answer. Let's think about it. X is 1.0 times 10 to the negative 5th molar. And so that is equal to Hg2+. So that means concentration of mercury ions at equilibrium, it's going to be 1.0 times 10 to the negative 5th molar. But as we can see, chloride ions are not equal to X, they're equal to 2X. And so the question asked is said, what is the molar concentration of the Cl ion? It's only interested in chlorine. It's only interested in chloride ions. And so because of that, instead of just saying X, we just got to multiply it by 2. So the last thing we're going to do, times 2, and that's because of the 2X relationship for chloride ions at equilibrium, okay? And I end up getting the final concentration of Cl minus is equal to 2.0. Wow, 1 times 2 is 2. Like that. So that's our actual answer. All right, that's our actual answer. Ice tables are an excellent way to organize your thoughts. Just don't forget what they actually mean. Okay? Let's take a look at number 10, which I hate. I mean, I love. Number 10 is a great problem that I didn't have any issues with. And my wife and I definitely were not arguing about it this morning. All right, let's take a look at number 10. Calculate the molar solubility of lead sulfate in 0.01 molar of sodium sulfate solution. So what's our common ion? Sulfate. All right, that's the common ion here. So basically, we've got to look at the stoichiometry just a little bit. I'm going to start by breaking down lead SO4, lead sulfate. So we've got PbSO4 is going to end up becoming Pb2 plus SO4 2 minus. Okay, and then I'm going to do another one for sodium sulfate over here on the right side. So I can say, all right, well, okay, there we go. Now, the number that they give us is 0.01. That's the number that they give us. And so we can say, all right, well, that means this number here is going to be 0.01 molar, all right, of this overall. And I know you guys are going to realize, you're going to say, well, Mr. Aaron, I thought you said that was a solid. It is a solid, but just know that that 0.01 molar refers to that, all right? So if we look at it in terms of stoichiometry then, because there's 2 moles of sodium for every 1 mole of Na2SO4, that means this is going to be at a concentration of 0.02 molar, twice as much in solution. And this one's only going to be 0.01 molar. It is a 1-to-1 ratio between sulfate ion and the sodium sulfate salt. Okay, it's a 1-to-1 ratio between the two. And that's all just based on stoichiometry is how I get those numbers. Now, based on that, our common ion is sulfate. Common ion is sulfate. And so based on that, I can carry that. And this is the only way my wife and I were able to explain it. This is the only way we were able to justify the answer here. That is the only number that we have. That is also the only link from one equation to the other equation. And so what we basically said is we said, all right, well, if it's 0.01 molar, 1-to-1 ratio for sodium sulfate, then why couldn't that also be the concentration of this in our lead sulfate? Okay, so we just carried the 0.01 over because of common ions. And so then what we had to say was, well, if it's a 1-to-1 ratio, then, well, that's going to be 0.01 molar. This is going to be 0.01 molar. And because it's 1-to-1-to-1, this is going to be 0.01 molar as well. So our thought process was, based on stoichiometry for sodium sulfate, based on the common ion relationship, we were forced to say that it's going to be 0.01 molar lead sulfate. And honestly, guys, even after talking about it, we still ended up putting a star by that because we weren't really happy with it, but that's what we got. We're running out of time, so I'm going to keep moving. Number 11. When solid potassium chloride is added to a saturated solution of silver chloride and water, okay, what's going to happen? I'm just going to explain the right answer because I know you guys probably want to get off the computer. Lunch is coming up soon. Let's take a look at A. Solubility of silver chloride decreases, and here's why. Common ion effect. Okay, once again, it comes back to the common ion effect. So basically, the extra Cl ions are going to shift equilibrium. You guys remember Le Chatelier's principle, hopefully. And it shifts it back towards your AgCl solid. Okay, think about it. You add more chloride ions, you increase reactant products, it's going to shift back towards the reactant side. So if you have those extra chloride ions, it's going to shift it back towards the solid. And so what that means, therefore, it creates more solid and less ions. And so that was our thought process there for number 11. Number 12, calcium carbonate and barium carbonate have KSP values of that and that. If water is shaken up with both solids till equilibrium is reached, the molar concentration of carbonate ion is what? All right, so we're trying to find out what it is. What in the world are we doing? All right, easiest thing to do is we're going to go ahead and start by writing out, again, what all this stuff means. So calcium carbonate is going to look something like that, as you know. It's going to end up becoming calcium ions plus carbonate ions. So, hey, 1-to-1-to-1, that's kind of nice. And then we're going to have another one for barium carbonate as well. So I got to do another one for barium carbonate. Here we go. So over here, we'll say, all right, well, barium carbonate, it's going to end up becoming Ba plus 2 plus CO3, 2 minus. Okay, and so once again, 1-to-1-to-1. So I could write full ice tables for all of this, but what's really important is you end up getting plus x, and over here, same thing, plus x, plus x. Everything's going to increase by x when you dissolve it in a solution. And so what that means then is that if you're looking at the KSP for the one on the left, for instance, KSP is going to be equal to blah, 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 Ca2 plus, CO3, 2 minus. But because it's 1-to-1, right, because it's 1-to-1, we end up getting just x times x, which obviously becomes x squared. Okay, squared, there we go. Same thing is true over here. I'm not even going to show you all the work, but basically KSP ends up equaling x squared over here as well. And again, I'm just shortening a little bit. You could do full ice tables here as well. I'm just trying to speed things up a little bit. And if you want to, I recommend you try it. Make full ice tables for both, and maybe that'll help you understand a little bit better. Now, at this point, they give us KSP numerical values, and so I'm just going to plug them in where they belong. So for calcium carbonate, it was 1.0 times 10 to the negative 8, so that's equal to x squared. And for barium carbonate, it was 5.0 times 10 to the negative 9th was equal to x squared. And so obviously, we're going to end up doing some math here. Okay, we're going to end up doing some math. So math happens, you just do the square root of both. So over here, x is equal to 1.0 times 10 to the negative 4th molar. And so that's going to be equal to the concentration of CO3, for instance, just from calcium carbonate. Because remember, all of this relates back to x. And for this side, x is equal to the concentration of CO3. All right? Same thing on the right side. Math happens. I ended up getting x equals 7.1 times 10 to the negative 5th molar. And so what that means is x, once again, up here at the top for this ice table, was equal to concentration of CO3. So that is also equal concentration of CO3. And so you may be thinking, well, Mr. Nairn, which one do we end up using? Remember, this is this water that has both solids. They're both going to be shaken up. And so based on the equilibrium of both of them, okay, you just have to add them up. You just have to add them together. So to get your total, think of it this way. We're looking for total CO3 concentration. You just add them up. 1.0 times 10 to the negative 4th molar from this side, plus 7.1 times 10 to the negative 5th molar from this side, and I end up getting 1.7 times 10 to the negative 4th molar with some sig figs. And that was my full answer. Okay, guys, that's the worksheet. That's the best I can do for you right now. Does anybody have any other questions? I'm gonna give some time for the delay. If you don't need anything, I hope you have a good one. If you have any questions about AP stuff, you can talk to me or Miss Burlingame. But I recommend you use the resources I've provided. Also, they have a bunch of videos that I gave you guys as well. If you look on here, this link right here about the AP 2020 exams, that has several videos that are provided from College Board that are meant to help you understand the AP exam. So if my explanation was poor, you can go to that. But do you guys have any other questions for me before I log off? Now we've entered the Q&A section. And once again, guys, if you don't say anything, that doesn't tell me anything. If nobody says anything in 60 seconds, see you, Lauren. Have a good one. If nobody says anything in 60 seconds, I'm just going to sign off. No? Good. See you, Emily. Have a good one. See you, Cassie. Have a good one. All right, I'm going to end the stream. Thanks for watching.